Okay, I think everybody knows that we're going to restructure things a little bit. We got feedback from the homeworks that the transition to Python was not as smooth as we would like. It's a lot more time that's needed on this. So what we're going to do is we're going to spend some time over 3 class periods going into some of this in more depth. And the way our vehicle for doing this is really we're going to go through the homeworks. And so the structure is going to be that, get sort of deeper understanding and hopefully do this in class as well, is we'll have an opportunity, everybody will have an opportunity to spend a little bit of time in class if you like, or we could do this outside of class as well, but trying to solve some piece of a larger programming problem. And whoever's up here, and Dave and Kenneth and I will take turns doing that, will sort of direct you a bit. But the idea is that you may be able to figure it out all yourself. That's fine. I mean, this is not so much a test as much as an opportunity to explore. Or you can ask other students. I mean, just say, hey, does anybody know what the syntax is for an if statement? What am I missing here? Do I need a colon? You get credit for participating. It doesn't matter how much you do because everybody's at different places. We know that. But it's more a matter of having that experience of engaging in the problem solving. That's what we're really interested in, just that engagement. So, we're hoping that it'll all be viewed as a positive, supportive type of thing. Anybody who participates gets 10 points. It doesn't matter how much you do or how little you do. We figure that all this is going to be a learning experience. It's going to be learning for us as well because we want to understand at what point things don't make sense. What are the things that seem to be stopping you from understanding or where we need to have more depth. So for us, it's also a very great opportunity to improve our teaching. So that's what it's all about. Let's see, I think Dave already mentioned, there's an attendance sheet that's circulating. We just want to sort of keep track of, how the participation's going, just in terms of attendance. And then separately, Kenneth is going to keep track of who participates in the in-class problem solving. So there's no sign up, there's no particular order. I mean, the only thing is we want to make sure everybody gets a chance to do it once before give others a chance to do it a second time. I've already had one student approach me by email and say that they'd like to have a private session. If you're not a particularly public person, this is not a public speaking class, so that should not be a barrier if you prefer to do it privately. But I think that part of the advantage of doing it publicly, if you're willing to sort of take the chance, is that you will get interaction with other students. I mean, that's really what this is intended to be. It's a positive, constructive way, not a test, not, you're on edge here, but just a constructive way of trying to figure it out and also for us seeing more what's going on. So what I'm going to do is I'm going to go through homework 8. That's going to be the problem we're going to solve. How many people turned in homework 8? Okay, so a few. Okay, now of those people who turned in homework 8, how many people felt that they got to the point where it was really working? Okay? All right, that's fine. I mean, this is exactly what we want to see is, okay, so that's good. So, I mean, it's actually, the net of it is it's a small fraction of the class. So, it's good to take a pause here. All right, so the way I'm going to do this, these slides are posted. These are the notes for today. The way we'll do the in-class participation is I'm going to bring up an IPython notebook. And all this is recorded like we have been doing. We're recording this. Get rid of that. Okay, maximize this. Okay, that's pretty visible? Back in the back? Can you see that okay? All right. Can I reopen it? Yeah. Oh, you want me to go through the sequence of using IPython Notebook? Got it. Okay, so yes, absolutely. Let me do that because I'm posting IPython Notebooks, and that's a really good point. It may be that the use of IPython Notebook is sort of problematic too. Okay, so I'm going to start all over here. Now, I'm doing this on a Mac. It will be similar on Windows, but not exactly the same. Okay, and I will describe what it is that's different here. Let's see, this must be the... Okay. Oops. Okay, all right. Okay, so the first thing you do is to open the IPython notebook. I'm assuming that you have it installed. How many people have installed IPython notebook? Okay, it seems like almost everybody has installed it. If you're having problems with an install, then please talk to somebody in office hours. I mean, IPython Notebook is really very helpful to have. If for some reason there's a problem with using IPython Notebook, we can also export the code as just straight Python, and then you can run it from the command line too. But IPython Notebook just provides so much more. Okay, so whether you're in Windows or you're in the Mac, you get to a command line. Now, for the Mac, you get a bash prompt like I've got here. On Windows, I think you're probably going to have to be in command.exe. I don't think git bash works like this. I'm not positive. Has anybody, Ken, if you have a Windows machine, have you run IPython Notebook from git bash? Okay, so I'm not sure that, yes, have you? You have? Okay, so that does work. Okay, so that's wonderful to hear that somebody has done that. So, I mean, it's a little bit confusing because in the Windows environment, you have a couple of different shells you can work with. So it's great to hear that one student has been able to do this from git bash. What you'll do is when you get to the appropriate command prompt, you type in, so then the next consideration is you want to be in the directory where the IPython notebook lives. So what you'll have done is you will have done a git clone for this for the shared code repository. So on Git, there's a repository I've created called shared code. This one right here, shared code. And you will have had to have done a clone of that. Now you're already experienced with doing clones because that's the way you're turning in your homework. Right, so you will do that, and you'll see when you go. I can show you here. When we go over here to, let's see, let's just do git. All right. So yeah. Okay. So here's the repository, shared code, and you go there, and then you'll see that it's numbered by lecture. And then you just, you could, I mean, one thing you could do is copy it down, but, what you want to do is, as in the usual thing, is you go over here. Here is the clone address, the address of the repository. And then when you get into your environment over here, you would say, I'm not going to do it. I'm not actually going to enter it because I've already cloned it. I'd say git clone, and then I would type in that name, that path that I picked up over there. And this is the usual stuff that you've already been doing. If anybody's still having a problem with this, please see us in office hours. It's going to be very hard to do the work. So once you've cloned that, which I've already done, then you would go into that, then you would be in that directory. Let's see here, where am I? Oops, I guess I was already there. So here's what it should look like. It should look like shared code. So I go into shared code. And then when I see that, I'll see something by lecture. And we're looking at, today, lecture 11. So I go into lecture 11. When I look there, I see I've got this IPYNB is IPython Notebook. So that's what that means. And then I just enter in. So now that I'm in the same directory where that notebook lives, and I say IPython Notebook, just like that. And now what it'll do is it may take a minute or two to process things. Once it pulls itself together, it will bring up a web page, a tab in the browser, and oh, I mistyped it. I will wait a long time. Yes, okay, IPython Notebook. Okay, now let's try that. That looks a little better. Okay, so then it will eventually bring up a tab in the browser, and that will give me what they call the home tab, where I can either, any notebook that exists in that directory, it will show me, like I've got this lecture 11 notebook, or I could create a new notebook over here if I chose. Okay? Does that look reasonably familiar? I mean, again, we're recording this, so you'll have that to see, and I believe this is all documented in our notes too. Again, if you're having trouble with this, see us in office hours, let us know. Yes?
This is different from a Windows computer?
How is this different from Windows? At this point, it should be the same. Once you get to the point where you're typing IPython space notebook in the directory where you're, you have that Python notebook, it should look exactly the same. You should come up with the same thing. Okay, other questions? Okay, so what I'll do is I'll navigate to that notebook. Okay, and what I've done here is, homework 8 was a redo of homework 4 in Python. So homework 4 was Michaelis-Menten. And there were 4 or so scripts/functions we dealt with there in different pieces. And what I've done here is IPython Notebook allows us to enter both text and code. And so I've structured it so I said, okay, there are going to be 4 parts to this. We're going to do something which is going to plot the raw data. We're going to estimate the Michaelis-Menten parameters. We're going to plot the fitted data. And then we're going to pull it all together, sort of an overall script that does all these pieces in combination. Okay? All right, and that's just what we did in homework 4. And so what we're going to do, and so this, this particular exercise, structures nicely, is this is not code. This is just comment here because it's in a Python environment, and Python doesn't know how to run MATLAB. And so down here, where I actually have opportunity to enter in code, that's going to be the starting point for our first lucky volunteer. Okay. Would anybody like to start off? Get us out of. Okay. All right. So fine. All right. So I'll tell you what. You just volunteered. What's your name?
Karin.
Karin? Karin. Okay. I just make sure we're able to get you down here. Okay, Karin. And you know what I'm going to do just to make sure I don't lose track of time here? Let me do this. All right. Sorry. So I want to try and do about 10 minutes. Probably an egg timer would work even better. Okay. All right, Karin. You want to start with some data. Okay. So why do you want to put in data first?
Because in MATLAB, it's like everything is based off like the data that you're using. So you want to find means, averages, stuff like that. You need to have numbers to do stuff.
Okay, so Karin's comment is it wants to start out with some data, so there's something to work with. Okay, and that's fine. That's very reasonable. I mean, one of the other advantages is, and this is also something that I hope that everybody gets out of this experience, is this is an environment where you should be doing experiments just like you would be doing in a laboratory. You should try stuff. The nice thing about a programming environment is if you try stuff and it doesn't work, it doesn't matter. You haven't blown up anything. There's no glassware that's destroyed. Nobody's gotten any serious eye injuries. You can just try it. Don't be hesitant. Try it. Okay, so let's do that. I love that approach. The data is actually down here is the way the original solution. So what I did is I picked up the solution that Kenneth posted. Okay, so I'm just going to start by, to give you a start here, I'm just going to start by copying this. Now, again, this is a MATLAB statement. So how meaningful it is to copy something from MATLAB, we'll have to see. But I can certainly do this as a starting point. And oops, I'm sorry. I know what I did wrong. I switching between machines and I used the wrong. Okay, let's try this again. Let's do this. Let's do this. Do that. Okay. So that's the MATLAB command. What would you like to do different about this? Okay. I mean, so right away, Karin has a sort of a challenge. You have to choose what your data type is. Okay, so this is data, but what is it? I mean, it's a structure of some sort, right? Okay, so what do you want to do with this?
You have to add labels to it.
Okay.
And figure out what substrate concentration is and what the reaction rate is.
Okay.
You have to build 2 columns.
Okay, so you want to build 2 columns. You'd like to make a matrix out of this? Is that it, or something like that? That's a possibility? Okay, so Karin, you have, I mean, you're sort of leading the way here in terms of how these interactions are going to go. You're going to sort of, all your classmates are looking to you to see how scary this is and, what it is you need to actually do. Okay, so feel free to ask people. I would prefer not to give answers. I would prefer to have other people ask questions. And by the way, it's perfectly fair to ask a question or make a statement about how you might find stuff out. You know, for example, it's perfectly fair to say, well, gee, maybe we should go to a web browser and search something like Python MATLAB or Python arrays. So Karin is the guy who's going to, I'm not going to call on anybody. Karin's the one who's going to determine if anybody, you know, whoever to speak. If you want someone, go ahead. What do you want to do?
I remember in the lectures you mentioned you had to download one of the software packages that downloads Anaconda.
Yep, it is.
Anaconda, isn't that like, it's like math operations?
So Anaconda has a whole bunch of packages in it, including things that do mathematical operations.
So would it be better, instead of putting the data in first, to like import that package?
Well, we have, okay, so Anaconda is a whole bunch of packages. You don't, and Anaconda is what's called a distribution. It's really a collection of packages. You don't import Anaconda. What you do is you import one of the packages in Anaconda. So one of the packages in Anaconda is NumPy, which has a lot of math stuff in it. SciPy includes NumPy, has even more. It tends to be higher level, like linear algebra types of stuff. So, I mean, that certainly would be a possibility as well. So, okay, what would you, any thoughts about what's next?
So I feel like I would have to import NumPy.
Okay, you would like to import NumPy. I'll tell you what, I don't want to throw this away, so I'm just going to keep that there. I'm going to go up here. So we've got the cell is right here. Okay, so we're going to start out by import NumPy. Would you like to do it like this? Okay, so now one of the implications here, and this is actually important and potentially subtle, is this will depend on how you're going to call the NumPy functions.
Because there's stuff in NumPy.
There's stuff in NumPy. So do you know what's going to happen if we say import NumPy star? Yeah, right. Or if I just say import NumPy.
I don't know. Is it going to work?
Well, I mean, it's a matter of how you name it. I'll give you a little one hint here. If you say this, from NumPy, import star, then everything in NumPy at the top level is available to you. You don't have to worry about a name dot.
Oh, okay.
So we can do that. Okay, so we've got NumPy.
Is there a way to find out, can we open up the browser and see what kind of stuff is actually in NumPy?
Sure. Okay, so let's open up a browser and look at, oh, you know what? We've got a browser right here. That's right, we're in a browser. Okay, so why don't we call this NumPy, what would you like to call it? Or we can just say NumPy. All right. So let's see what's in NumPy.
Just to see what's in
Let's see, getting NumPy, what looks good here? Installing it, NumPy tutorial, maybe. Sometimes that's good in terms of finding what's there, the basics. Maybe, how about it, you want to do an array? Okay. All right, so here we've got some stuff. So this is, okay, so there are a few things we see here which is sort of interesting. It's just, yeah, I can make this a little bigger too. Okay. Is that readable in the back? Not yet. Okay. How about now? Can you read it? Not yet. All right. How about now? Okay, so now it's readable in the back. Let me do one more. Okay, that should be really readable. Okay, so we've got some things here which look sort of interesting. So what we did this same statement on the other page. We did the from NumPy import star, so it's available to us. Okay, so what looks interesting here? Making an array. Okay, so we can do an array. Okay, and that sounds good. Now, okay, all right. Now, we could certainly make an array. There are a few different kinds of arrays over here, which is sort of interesting. You probably are thinking about, more of a matrix. It's an array, but you'd like to have a couple of columns. So it looks like you can do that kind of stuff. Yeah. All right. So what I usually find is helpful here, rather than trying to remember the syntax, I just will usually copy it. And then if we go back over here, this should be okay reasonably. Okay, so we could just do this. And this is another thing which is very useful. Usually when you find examples, and by the way you will program, the way everybody programs, is you find an example that's sort of close to what you want to do, or a piece of sort of what you want to do. You copy it, and you paste it, and you run it. Okay? And you see if it works. Because if that doesn't work, if the example doesn't work, then you know there's a problem. Okay? All right, so let's just try that. Let's just try running this. Okay, so we'll run it. Okay, well it didn't complain. I guess we didn't do anything much with it. Suppose we say print B, and then we run it. What happens? Well, that's encouraging. Okay, I think we're off in the right direction because now at least. So this is, remember with Python, I spent a lot of time on data types. Okay, this is the root. You know, it may seem like you're just barely getting off of, you know, just barely starting if you focus on data types. But this is actually one of the harder parts. Okay, so I think we're off to a good start here. Okay, what would you like to do now? Let's go down to this line right over here. Now I'll run it again so we get the number right there. Ooh, okay. I didn't run it before, actually. Okay, we know that doesn't work because that's not Python. That's MATLAB. Okay, so now we're going to make that. I'll tell you what. Let me create a new line here. Actually, you know what might be good here is let me use this. Go up here and just say what that is so we don't get confused about. So let's see, oops, let's try like this. MATLAB data. Actually, you know what? Let me do it right here. And I think this works. I'm not positive. And then over here in IPython, you can say that this is actually text rather than code. And then you actually have to run the cell to be able to do it like that. So this is the MATLAB data. All right, and we can move this down. All right. Okay, so we won't confuse that this is something that's Python code. Okay, so what would you like to do with it?
Do we have to make two different arrays for the substrate concentration and reaction rate?
Well, and this is part of what you sort of have to figure out. We're going from the bottom up here. From right now, let's say we're doing a direct translation of this code. Okay, and what did we come in with? What was the argument to this function? Well, okay, so this function, plot Michaela's data, has its argument, data. Yeah, just what is data? Yeah, it's a matrix, right? It's, an n by 2 matrix. Okay? So, I mean, that would be probably, let's just assume we're going to do that. We're going to recreate whatever was present before. All right, so your 10 minutes are up. You get your points. We're on to the next volunteer. All right, just a second. Let me go over here, make sure I get, it's very easy to forget, get wrapped up in things, and I think having a timer is going to really help. Okay, who'd like to go next? Wonderful. I see all these volunteers. Please, what's your name? Michelle. Okay, Michelle. And you're good? Okay, all right, good. All right, Michelle, what are we going to do next? Okay, do you need it bigger? I can make this bigger. How's this? Is that better? Better? Okay, is that better with the contrast too? Okay, Michelle, the other thing you can do, feel free to come up here, because if it's difficult to see, feel free to come up or move around. I mean, you don't have to be at a keyboard. Yeah, that's a great idea. Thanks, Karen. Is there a question? Well, yeah. If it's procedural thing, that's fine. But Michelle's running the show now.
Okay, so I picked matrix instead of array.
Okay, that's fine. We don't have to keep on going in the same direction. What would you like to do? Do you want to say tell me what to type?
Well, so I'm a little confused because I imported the numpy, I said import numpy as NP, and I called it.
All right, fine. We can do that right here, and that's it. You know what? Let's do it the way you did it first, and then we'll go back and see how it will look the way Karen started it. Okay? So
I'm just not sure what do I call it with numpy?
Well, let's just do it the way you did it for right now. So what you did is you said import numpy as NP.
Yeah.
Okay? All right? All right, that sounds good. And so what this will do is instead of saying array like we did up here, or if you do it this way, okay, so then what would happen is that instead of saying array like we did up there, we would take this line over here. Actually, let's do this whole cell here so that we get the result coming out. Okay, and the difference is array, because array is part of NumPy. Since you said as NP, we'd have to say np.array. That's the difference.
So I did np.matrix.
Okay, all right. So I'm just going to run this just to show we end up with the same thing. And then let's get on to what you're doing. Okay, so let's see. Let's, okay, so what would you like me to type in?
Okay, so can I use data instead of b?
Yes, you can.
So data equals np.matrix, and then I formatted the data from the MATLAB data.
Okay, so let me just copy all of this, just the data part, to save us some time. And then you tell me what it is that you want to do with this.
Okay, so after the matrix, I do an open parentheses.
Okay, we've got an open paren. And then what?
I close parentheses.
Okay. And then close parentheses on the other side. That sounds like a plan.
And then I have to also do brackets around the whole thing, or like inside the parentheses, but outside of the whole thing.
Oh, okay, so you do. Okay, so you've got a square bracket here, and then a square. And why are you? Do you know what it is that you're doing with that?
It's like so when you see that output, it's kind of the first bracket, the last bracket, and then I want to do like individual brackets for each row.
Okay, so you want to do individual brackets for each row.
Yeah, and then I want to separate each number with a comma.
Gotcha, gotcha. So let me see if I'm doing the right thing you wanted. So you do it like this. Is this the kind of thing you're thinking? And then you got a comma in there?
Yeah.
Okay. Okay, so just so that it's clear what's going on here, because this is actually, it may seem sort of magical, because the syntax part, I think, are the things that are a part of what it is that people are having some problems with. I'm going to take this apart and do it in smaller pieces. So, Michelle, the part that you've got right there, I'm going to call this, let's see, I'm going to call this just list data. And then up here, we're going to have a new line, which is, because I think just the syntax part is sort of a challenge here. List data, this is what we're formatting. So what we've got up here, and actually I'm going to do it a little bit more even. I'm going to say, let's see, we've got substrate. Okay, substrate list. And that's one of the, well, actually that's not the way this is structured. You've got it by, actually let's do it first row. Let's see, I'm just going to do this as an example so everybody understands. Row 1 list. So what we're starting with here is 0.01, 0.11. Okay, that is the first experiment. This is the, I believe this was the substrate level, I believe. Yeah, that's the substrate level, and this is the reaction rate. I believe that's the way this works. Okay? Okay, so that's what the semantics are. That's for one experiment, one point on the plot. Okay, the square brackets on either side indicate that it's a list. A list is one of the basic data types in Python. The fact we've got, and it's a list of two. What kinds of data types are those? 0.11. What is it? Is it a string? It's a float, right? It's a float. So what we've got right here, row 1 list. This is a list. That's a Python list. Okay, and what Michelle is busy formatting for us is a list of lists. Because there's no problem with having a list of lists. So the first list is going to be row 1. What's the second list going to be? Row 2, exactly. Okay, so keep on going. Tell me what I have to do here. I've got a semicolon there. What should I do with that? Okay, and why should I delete that semicolon? And what should I put there instead? Comma. And why am I putting a comma in there? Is what? It is separating, but because that's the way you separate elements of a list. It's just since this is a list of lists, that second element of that upper list is a list. It's a list of 2 elements. Okay, let's keep going. We can do this pretty quickly. This is going to get boring very fast, right? All right. Okay, so yeah, where are we going here, Michelle? Keep on doing this?
Yeah.
All right, good. All right. All right. And last one here.
I think one of them is missing the end bracket, and then I want to put commas.
Okay, so let's see. Yes, it is right there. Okay, and this should, let's see what it do over here. Yeah, okay, do I need one right there? Okay, that looks good. That look reasonable. Now again, another thing to think about is it's very reasonable to have the computer check it for you. This is not a lab where you're going to destroy an experiment. The only thing that will happen is it'll say error. And as long as you don't have a super weak ego, then you're going to be fine. Nothing bad's going to happen. All right, so what we've got here is, this one right here was just to show you what that listed. We didn't actually even use it. This here defines the list, and what we're saying here is that the argument of matrix is a list of lists. Okay? I'm sorry?
Can you put commas in between the numbers that are in?
Oh, yes, I failed to do that. Thank you. Excellent. Right. So actually, you know what? I'm not going to do it. Let's see what happens. All right? And let's look at the error. So this is very important. You know it didn't work. Okay, that's sort of like the first level of feedback. The second level of feedback is why and what do I need to fix? Okay, invalid syntax. Okay, fine, I screwed up something. Do you see where over here it has that caret? See that little caret there? It's telling you where I screwed up. I somehow screwed up somewhere in here. Well, I don't have a comma there. That's the problem. Okay, so let's do what Michelle told me to do and put in the commas. Again, feel free to experiment. You know what? One thing I've always observed about people who are fairly proficient programmers is they're very good about figuring out when the computer will tell them the answer, and they don't need to figure it out. So if you have a syntax question, a lot of times just do it, see if it works, and if it fails, a lot of times the error diagnostics will tell you what you need to do wrong to correct it. If you don't know how to design a program, just trying stuff, you'll never get there. Yeah, because the computer won't help you with that. All right, so let's try running this again. All right, life looks much better. Okay, now I guess the other thing, what else would you have? You have about 30 seconds. So what else would you like to do?
Now I want to go back to import MATLAB.
Okay, so I'll tell you what, before we get there, because that's a whole other thing, let me just see what it is that you've got here. Because you actually got us quite a ways. I think you got us to the data. Okay, so everybody look at this. We've got a matrix in Python. This is a big deal because this is a lot of what we want to do. All right, okay, okay, got Michelle. Who's next? Okay.
I did something different. Instead of putting all those brackets in between, I did data reshape 6,2.
Okay, so what you're saying is then what you did, let's see, let's do one more row down here. Okay, so you did, so instead of putting all the comments, you said data.reshape 6,2. But you didn't define data the same way, you're saying. You did it a different way? Did you do it? Well, I think what you did was you probably did what row? You did like a list of 2 lists. This is a list of 6 lists. That's probably what you did. So you made it from, you know, you started out with probably, I'll tell you what, I'm sorry, what's your name? Christine. I think what you did, Christine, is, let's see, if we reshape this, I think we'll get what you originally constructed. So we got this. And so what you did is you had 2 rows. That's, I'm guessing.
Instead of the brackets, like all those brackets, I did,
Oh, you did it one linear sequence?
yeah,
And then you reshaped it. Okay, and that's fine. That's actually a little more sophisticated. But, you know, eventually you got it into this format, I assume? Okay, all right, fine. Why don't you take us from there? Because there are a lot of different ways, and that actually is a really good point. That's another thing you could have done.
and then the next line, I did substrate equals to open quote THCPA and close quote.
Okay, substrate equals, I'm sorry.
Open quote.
Oh, okay, okay. So you're writing the THDPA.
Yeah.
Okay, and then, Okay. All right, and then let's just run that cell, see where we are. All right, good. Oops. All right. All right, so now what are you going to do? You're going to actually start us with a function.
Yeah.
I'm sorry, what did you call it? You called pros data? Oh, plot data. Okay.
And then open parentheses, data, xlab.
xlab, okay, like xlabel, right.
Yeah, and then close parentheses and colon.
Okay. All right.
The next line. So,
Okay, so just 1 second here. So this line, actually, you know what, let me move this up for just a second so we can see it. Let's see, def. Yeah, okay, so now at least you can see it somewhat. Okay, let's do it right here. Okay, so this is actually sort of important, what you're saying here, because this line here, this def plot data, data comma xlab, it's a little bit more than what this says here, which is fine. There's no problem with that. But this is the equivalent. These are the equivalent statements between MATLAB and Python. And I know that the syntax is something that has been problematic for people. Okay? Okay, now the difference is that we've got an extra argument over here. We'd have to type in another argument over there to make them the same. But if we did this, you know, if we took that out, that actually would be the same. Those are equivalent. Okay? That helpful to people? Because that difference, I think, is okay. So I'm going to put it back. Lab. All right. Let's go down. Okay. Yeah, there's where we are. Okay, so what's next?
also, underneath from NumPy part, I did import matplotlib.pyplot.sp.
Okay, let's put that up here. So import, you did plot. It's FP? Like that? Oh, as P. I'm sorry. Okay, I apologize. All right, fine. Yeah, okay. I mean, yeah, there are a few different ways you can do this, but again, we see one of the important things that's going on here, a couple things, is first of all, you have to know the package you need to do plotting. Okay, and there are a few different ways you can do this, and you got one of them, and which is fine. You only need one. The second thing is you have to figure out how you're going to do the import. Are you going to do it, you know, like we're doing up here, you know, from NumPy import star? In which case, you know, you could do the same type of thing here. You could say from matplotlib.pyplot import star. You could do the same thing, and then it's available to you directly. Otherwise, you're going to have a p dot in front if you do it like this, which is fine. I mean, this has the advantage of this avoids what are called name collisions or name conflicts, where you have the same name from different sources. Okay, what else? So bracket, colon, comma. Okay, 0, okay. Okay. Okay, so okay, you know what? For right now, I think I'm going to move this up just close to the MATLAB stuff because this is really important to be able to see the relationship between the two. Let me do this down a little bit. There. Okay. So what you're doing right here, this is actually parallel to this statement right there. Right. And it's actually, the syntax is actually very familiar. Okay, but wait a second. We used a 1 here, you used a 0 there. Why'd you use a 0 and not a 1? Python starts from 0. And this is one of those things that sort of varies from language to language. Exactly. Okay. All right? All right, go ahead. What's next?
comma,
Okay, so that looks really similar. And so by working with this package pyplot, we're able to have a syntax that looks pretty much like what we would have done for plotting in MATLAB, which is a big advantage. Okay, what's next?
p.xlabel, open parenthesis, xlab, comma, font size equals to 20.
I've forgotten how that, what's the case and the spelling on that? I've forgotten how that works. Okay, oh, okay, it's all lowercase and no underscore? Okay, equals 20? Okay. Okay.
And then p.ylabel, open parenthesis, open single quote, b close quote, comma, font size equals to 20.
Okay, so did people see what's going on here with this? So this is a way, this corresponds to the defining an X label up here. And so this is in this MATLAB code up here, we actually put two statements on one line. We've got X label here and Y label there. And what you've done is it's really exactly corresponds to that, where here it's in a string is used, but over here, well, actually, yeah, over here we're actually passing the value in. Oh, I say lab, I meant xlab. We actually pass that in the function, and we have a similar kind of idea with specifying font sizes. Although I guess this solution here doesn't specify the font sizes. Okay, what else? Yeah, Dave.
Well, Christine, can I just ask how you figured out the font size argument? Like, did you look up that function on that plot?
So this, yeah, but I'm just going to repeat, Dave, for the recording. Right. So the question was, how did you figure out the font size argument? You Google it, and that's exactly the right thing to do. That's great. Okay, you know what? You're almost out of time. I think you've got things pretty close here. Was there anything else? Oh, you wanted to do a title?
One last line.
Okay.
P.access, open parenthesis, open bracket, 0, comma, 1, comma, 0, comma, 0.3, close bracket, and close parenthesis.
Okay. All right. Okay. So the first thing to do when you get a function, when you define a function, is make sure that it just will compile it. It's defined okay. You don't have a syntax error, and so you just try running it, and that's just running the definition. And then the next thing you would like to do is actually invoke it. Okay. So to run this, well, what do we need to do to run this function? Okay. Well, we're going to need the data. We've got data. Okay. We just defined data, so we would have to say plot underscore data. Data, we actually call it data, and we'll use an X label of, let's say, THDPA, and let's see what happens when we run this. Oh, yeah, okay. You know why you don't see anything? Okay, you can. It actually appears in a different window. Is the reason why you don't see anything. And if we do it like this, let's see here. Let's see where it went. I'm not sure where did it go. Hang on just a second. I was going to say there's another solution to this for.
What's the solution, Chris?
Do you know what this is? So part of the problem is there's a. This is another thing that you can Google. So %matplotlib inline, right? And this says when you run something, put the plot in with everything into your environment. And so now we actually see it. Did I get, oh, you're right. I've got a mistake there. Okay. All right. So now I can run it again. Okay. And why didn't that work? Exactly. I didn't run this again. I defined the function, but I didn't actually run it, so it didn't see the change. And so now when I run it, it actually looks right.
So running is almost the same as like a save.
It's like a save, right? It changes the environment. Okay, all right, so thank you very much. That was great. All right, let me set up for the next person. Okay, so who wants to be next? Okay. What? I'm sorry, what's your name? Heather. Heather. Okay, you've got Heather okay, Kenneth? All right, good. All right, Heather. So Heather, just a second. Let me get this. I'm going to move this down so we keep everything in sequence. All right, where am I here? I think I want to keep on going down and down. Yeah, that looks good. And then, okay, so keeping that there is fine. Let me move this down too, just so we keep it all in sequence. Yeah, I think this is right. Okay, good. I'll save it right there. Okay, and all right. So, Heather, any comments on what we've got right now, this particular piece? Otherwise, we're going to go on to the next piece. Okay. Okay, all right, fine. Let's just keep on going then. Okay, so here's the next piece we want to do. We want to estimate the Michaelis-Menten parameters. All right, so this was the MATLAB code here, and we're given data, and we've actually, I mean, a lot of the work is you know, Karen helped us with because he got it into a matrix. And so that's cool. We've got, or actually, and actually, there are a couple people, you know, Michelle as well. You know, between everybody here, we got it into a matrix format. So we got it into a matrix format. So we know we've got the right format there. Now we've got these. We've got to define a function, and then we've got to go through and do these steps. Okay. So what do you want to do for us? Okay. Okay, so what do you want to call it? I'm sorry.
Just like defining the function, right? So I just did
BEF? Oh, okay, I've got DEF. I've got def.
And then like functions FUNC. And then once you do it for your X data, so you have to put data 0
Okay, so do you want to put data as the argument, or you want data 0 as? Okay, so this is in your definition of the function? I'm not. Okay, so you're going to define an x and a y here as input, or?
Oh, sorry. Actually, what I did was x and then b max.
Okay, so the arguments of the function are x, v max, km. Okay, so all right. So I want to make sure I got the definition right that you're proposing. You're saying that the function, that the first argument of the function is x, the second argument is v max, the third argument is km. Did I understand you right? Okay. So and why are you using? Are you expecting v max and km to be supplied to the function? You want to return them, right?
I want to solve for it.
You want to solve for it. So I mean, the usual. There are ways that you could do this kind of thing in Python. I mean, typically, unlike MATLAB, where it specifies what the outputs are in the function definition, it's a little bit more involved. In Python, typically what you would do for this is you would return it in the return statement. You would document what it is. So I'll be curious to see how this works out. It's a little bit non-Python, but that's okay. Let's see where you go with it. It's okay. I mean, let's see where you go with it. Like I said, I think what's happening here is, and this is a standard thing, when you're used to one language, you try and do things in the same way in another language, and this is always a challenge. Okay, so what do you want to do? Let's go down to the internals of the function. What do you want to do?
I want to return a function. So my function is just making all the implementation. So just return my v max times x divided by parentheses km plus x.
Vmax.
You return and then space Vmax times x divided by k plus x.
Did I get that right?
Yeah.
Okay. So, okay. Well, let's see what happens here. So what, first of all, let's talk about what it is you've got here. Let's sort of document, because that's a lot of times very useful too. We want to document what you've got here. So your input is x, and what is x?
Like I usually when I'm using this, so I use to solve for my x, right? So I use the like SSR method, so I have to use another.
So you've got, there's another function here.
Like I need to have like I use nonlinear least squares to get my function to an address. So right now I'm not defining anything for my function yet. I'm trying to solve for like unknowns. So I just use.
Okay. So you're trying to do, so you're not trying to actually just translate this code here. You're trying to do something different?
Oh, because like even for the, like when I do my MATLAB code, I just get the SSR method.
Okay.
Follow this method.
Okay. Well, let's just, I mean, you know, for the purpose of this exercise, let's just try and translate this code, because then that would, because this isn't so much a class in scientific computing as much as a class in software engineering. It's more a matter of just understanding the code. I mean, there are a variety of methods. I'm not saying that the doing it this way is the only way, or necessarily even the best way. For example, over here, let's just try one line at a time. For right now, let's assume, I'm going to do this a little bit differently. I'm going to assume that what we're coming in with is data where data is a, it's a 2, it's a 6, well, let's see, it's actually an n by 2 matrix. And the column 1 is, I guess we decided was substrate. Column 2 is V. Okay, so that's what we're given. Okay, and let's try and do just the first line here. So inverse data, because that's fine. So we've got data coming in, and we want to compute the inverse of it. So what do? So we're just trying to translate this line right here. So again, I know you solved it a different way, but just for the purposes of this, because again, it's more about software engineering than anything else. I'll tell you what is often helpful here. When you get to a point you're not too sure what that's going to do. Okay, so we have data already. We can print data. That's a variable that we've already been working with. Okay, and we see that that's a matrix. Okay, so we can try stuff. So one thing to do is just, okay, what might you do? Okay, let's try it. 1 divided by data. Let's see what happens. That's cool. That works. Okay, so now what are we going to type in over here? Yeah, how about 1 divided by data, just like you did down here? Because that'll give you this. I mean, you've seen that. You already did the division. Now you know what you've got here. You've got inverse data. Okay? All right. Okay, so now what we want to do is we're going to create, okay, so there's this matrix here of 1. So this is, so RepMat and MATLAB, you're familiar with that? You know what that does? So it says that the first argument of, so part of this involves understanding the MATLAB part too. So this is, the first argument is what it is I'm repeating. And then the next 2 arguments is the size of the matrix that I'm creating. So how about size of data comma 1? Do you know what that does? That gives you the number of rows. Okay, so this is going to give me the number of rows. So it's going to give me 1s with equal to, it's a single column with the number of rows is the same as the number of rows in the original matrix, and it's only a single column because it's the one over here. So it's a number of rows, comma 1 is the size of the matrix. Okay, so we've got to do something equivalent to that. So let's work on that down here. This is going to be our working area. How are we going to create this one mat? You know, this column of ones. I guess the first step is let's start in here. How do we find out the size of data in Python? We know how to do it in MATLAB. We use size. How do we do it in Python? And by the way, keep in mind, I know people haven't taken advantage of this much. Feel free to ask your classmates, too. I mean, you can do it yourself, or you can ask your classmates. It's up to you. You can do it either way.
Or you can ask Google.
Or you can ask Google. That's true, too. Okay, you want to try that? Like length, data? You want to try something like that? LEN? Okay, you want to try LEN? Data? Now, right away, we've got a hint here. When something goes green, it's a reserved keyword. Sounds like it's something that Python knows about, so that's always encouraging. Okay, that's cool. Okay, that seems to work. The one thing you've got to be careful about here is what LEN really means in Python. It doesn't mean the number of rows. It means the size of the largest dimension. You got to be a little careful of that. So you probably want to find, probably when you do something different. But I'm going to pause right here because I want to make sure we, don't go beyond our 10 minutes per person. And just a second, let me set up for another 10. Okay. Who'd like to go next? Yeah. Anybody? Somebody want to go next? Okay, great. Okay. And your name is?
Juliet.
Juliet? Okay, Juliet. All right, great. All right, so what do you want to do here in terms of figuring out the number of rows?
Well, I just since there weren't that many rows, I just counted.
Okay, but you don't know, you're writing a program here that's going to be used generally.
I didn't do the size.
Okay, well then let's figure this out, okay? So let's see. You know what Dave back there gave us a hint. He said what you can do is ask Google. All right? All right, what would you type in? What would be some good search terms?
Python find size of.
That sounds great. Okay. Size or dimensions of matrix and NumPy. So if those of you haven't run into it yet, Stack Overflow. Whenever you hit a search result for Stack Overflow, I would say 80% of the time that has my answer. So I'm always excited when I see a Stack Overflow result. Okay, so generally what I do is rather than reading all this, I go down to the answer. Okay, shape. Sounds like shape is going to be very interesting. Yes, we'll return a tuple, m comma n, where the first one is the number of rows, second one is the number of columns. So you see what happened there? We had no clue what this was. We typed in a Google search, we saw Stack Overflow, and we just scrolled down to the answer. That's pretty nice. Okay, so let's go back here. So the answer is let's use shape. Okay, so let's go back here. Instead of, let's do data. I don't even remember what the format was of that. Okay, it is shape. All right, fine. So data.shape. Okay, and here's what we've got. Well, that's nice. That looks like a lot about like what you would get from size in MATLAB, doesn't it? Okay, so Juliet, what do we do?
So you could, in like another line, you could say one mat equals np dot ones, and then parentheses.
Okay, tell you what, let's do this a smaller step at a time. Let's say, I'm going to say, let's just have, we're going to add a new variable in here called rows, or n rows. Okay, how are we going to find n rows? That's the number of rows. That's going to be this 6 over here. How are we going to find that from shape?
Data.shape bracket.
Go ahead, do it. Do it. Say it. You want to say it. I can tell.
I can't think of
Well, okay, when you do indexing in Python, how do you start? 1, 0, 0. Okay, let's see if that actually works. Let's do that right over here. Let's just copy, and this is a really good habit. Just have a cell down here where you're doing stuff, okay, and then run it and see what happens. Oh, I didn't print it. Print n rows. All right, that's encouraging. Very encouraging because you get a feeling that you're on the right track. Okay, so now we've solved that part of the puzzle. Now let me hear the rest of what you've got.
So 1 mat equals np dot 1 parentheses.
Is it 1 or ones? With a 0, with an S. Okay.
Parentheses, n rows, comma 1, and then 2 close parentheses.
And then, okay, so the parentheses part, I'm not sure I got right for you here. So it's okay, np dot ones. Okay, so you get a left paren, and I have n rows comma 1. I'm not sure I got your syntax right.
I put 2 parentheses on each side.
Oh, you put 2 parentheses, so you got 2 parentheses here? Oh, okay. Oh, the argument is a tuple. That's interesting. Okay, all right. Actually, you know what? This is another one. Let's take this. I would really suggest we try this first. And we'll do this. And we'll do this. And let's see what happens when we run it. Okay. It doesn't want to. Why is it?
Unequal number of parentheses.
Yes, it is. Okay. All right. Let's try it again. All right. Looks good. Now, so what this has done here, which is sort of interesting, and I don't know if this was your intent or not, it looks like this structure here has created, okay, so I guess it's, I'm just sort of curious, what happens if we take, is this, I don't know if this actually takes a tuple as an argument. Do we get a complaint if we do this? Yeah, we do. Okay. All right, it does actually take a tuple as an argument. So, I mean, this is part of the thing with knowing the right data types here. So when you do this, let's go back over here, and you're starting to type in. So what does it take as an, it should, okay. Let's see, does Python, okay. If we do it like this, what does it tell me? No. Okay, yeah, I mean, the thing is, what Juliet has done is she's figured out the format for the command, which is usually the big challenge here. The point is that these inner parentheses, what they're doing is they are, it's creating another data type called a tuple. So n1s apparently takes one, it can take one argument, but that argument has to have all the information about what it is that you're generating, which is a tuple. Okay. All right, so fine. So far, so good. So that gets us our ones. Okay, what's next?
So if you look at the MATLAB code for xog,
Okay.
I like Googled a whole bunch of stuff.
Yep.
And so first I made, I defined a new variable that would only take the first column of the.
Okay. What's your variable?
First c equals, and then.
I'm sorry. What was it? I didn't hear that.
C.
First C.
Yeah. Equals, then inv data.
Of data like this.
The name of.
Oh, inv data. Oh, okay. Oh, gotcha. Inv data. Okay.
And then bracket, colon, comma, 0.
Okay. All right. Fine. Gotcha. So you're picking out the columns. Okay. And then you're going to do a second C. Or what are you going to do?
I made the x on AUG, that was from MATLAB, and then I put x on equals h stack.
H stack.
Yeah. Parentheses. 1 math.
Okay. One math.
Bracket. And then 0, colon 6. Close bracket. And then comma.
Okay. Then comma. Where's the comma go? Comma goes after the bracket. After.
After the bracket.
Okay.
And then first C.
Okay, gotcha.
And then close bracket, close bracket.
Okay, so that's very interesting. Let's try this. Again, it's a good idea to just see what it is that we're actually, no, I'm going to make this a little bit easier, and instead of, I was going to say print. Okay, and what does that do? Name error, first C, oh, I didn't include that. I haven't run that before. Okay. Name error in, what? Oh, I guess, okay, fine. Include that too. All right. Okay, so this is good. This is important to make sure you know what it is that you've got. All right. So, okay. So it looks like, I'm sorry? So that's a good question. Juliet, do you describe what HStack does?
I think it binds the columns into one matrix.
Okay, I mean, it's doing something like that. What we could do here to actually answer that question, and actually, this is a good thing because there are different roles here. So you're trying to write code. Karen may be trying to read the code you wrote. And so he may ask the question, wow, you know, Juliet must really know this stuff well. I mean, she's using HStack. What is HStack? Okay, so so let's look at Python HStack. Okay, here's a manual entry, and there's also a Stack Overflow entry. The manual is probably what we want to answer right now. Stacks arrays horizontally. Yeah, right. Okay, so and you can see some examples over here. Allow you to work with it. So that's a very common way of dealing with this. Okay, all right. Okay, so let's see, where are we right now? So, okay, so Juliet, at this point you've got us to Python code. Okay, so that's the augmented matrix. So you got us to right here. Okay, and actually let's just double check, make sure that the code is okay in terms of syntax. Okay, so I was able to run this cell, which means I was able to compile it in Python, so your syntax is fine. Okay, let's go on to someone else. Who else would like to try this? Still have some time here. Here we go. Okay. All those people who have done this already, Karen, Juliet, Michelle, raise your hands who's done it. Okay, 1, 2, 3, 4, okay. Could you show us if you have any visible wounds? Your head's still there, everything is still in place, right? No scars, okay? So there's nothing to fear here, all right? Your classmates are still standing and the blood has not been excessive, all right. One other, someone else? How about in the back row, someone? Okay. This is an opportunity to, you know, really understand the material much better.
One of you guys in the back row actually turned it in, right?
Yeah? I mean, it's actually pretty close right now. Now, the next line, I'll admit, it's going to take a little bit of work because that's where we're doing, you know, the matrix manipulations. But I'll give you a hint that it's not that bad. What we'll do is we'll just Google Python matrix inverse. That's the way we'll figure this out. You want to try it? Sure you can. How about the two of you can do it together? All right? That way it's a shared responsibility. Okay? You still get the full 10 points. What are your names? I'm sorry. Hazar and Hamran? Cameron. Cameron. Okay, Cameron and Hazar. Okay, great. And Kenneth, you found them okay? Okay, great. So this is a shared responsibility here. Okay. Okay, great. So now we're going to do this next line here. This may very well take the two of you the entire time because there's a lot there potentially. All right. And I'll be really helpful. I'll get you started. All right. I didn't do too much. Okay, so, all right, so what have we got to do here? Let's take it apart piece by piece. All right, let's say here, okay, let's start with this xaug thing. Okay, so what we've got over here is we're going to, okay, so this MATLAB statement, let's start with that. What's going on with this MATLAB statement? Right here, this xog dot, single quote, asterisk, xog. Well, I'm not. Let's forget the P and INV for right now, and just let the argument of P INV. So again, what we're doing, it's a divide and conquer thing. We're working from the inside out because it's a really messy thing. So let's just look at this part here. Let's see if I can highlight it. Yeah, just this is the only piece I'm going to worry about right now. So that is, we're multiplying the matrix by its transpose. Okay, so let's see if we can figure out how to do that in Python. So I guess the first step is what? If we're going to multiply a matrix, I guess there are two things. We have to know how to multiply a matrix, and we have to know how to compute a transpose. All right? Any thoughts about that? Either one of them. Or any thoughts about how you would figure it out? Because that's also valid. I mean, in programming, a lot of times it's all about, you know, I don't know the answer, but do I know how to figure it out? Oh, ooh, you've been listening. Great. Okay. What would be a good search term? Okay. Well, okay, good. So we've got here. Okay, so it's in NumPy and in matrix and transpose. That sounds good. Oh, an example. I love examples. Examples are the way you code. Okay, so what do you see? Can you, this is really tiny and you're way in the back there. Okay, is that better? Okay, what does it look like we can do? So we see that A here is a NumPy array. So what we've got, our D is actually a matrix. So hopefully this will work for, we don't know about how to do this with a matrix yet, just an array. Let's see. Okay, so the issue, what we could do here, I mean, here's something we can do that's really easy. Let's try and, this says A.transpose will work over there. Okay, and so what we could do is just copy and paste, and then say A.transpose, and see what happens. Or let's say, let's print that. And we can just run this cell here. Okay, and so, and then, oh, actually, let's do a print A, so we can see the difference. All right, so this is A, 1, 2, 3, 4, and this is A transpose, 1, 3, 2, 4. So that looks good. That's encouraging. What's the bad news? So we're working with this thing, data, and various manipulations of data. The bad news is that when we talked about data over here, when we created data, data is not an array, data is a matrix. This may or may not work with data, but we should try it. Because maybe it will work with data. We don't know. But we have to keep that in mind. Okay, so we've got that there. Let's just go down here. We'll do another one. Okay, so what would you like me to try? No, we're just going to try it. What should I type in just to try it? Sounds good. All right, let's run it. We are in luck. All right, good. Okay, so now what else do we want to do here? We've got the, okay, so we know how to do the transpose. That's really good. That takes us through about this much. Now we've got to do the multiplication. All right? Now, remember, there's no glassware that will explode if you get it wrong. What would you suggest we do? I'll get you started here a little bit for this. Let's see here. Print A transpose times. I'm sorry? Well, so what we're trying to do is we're trying to, this next line here, we're trying to do this, all of this over here. Right now, we're just working with this piece right here. Okay, so we actually do have, let's see, I think we actually did compute, I think we already have xog. Actually, we can work directly with XOG. Let's see. I think we've already computed that. X, AUG. I think that already exists in our space. No, it doesn't yet. Okay. So we're trying to do this. I think we got. Let's see here. If we do this, I think that'll give us XOG. We do this, and that's not going to work because, oops, there. We run that. Okay, so we do have XOG. Okay, so here's XOG. Okay, and what we've been doing before, we were doing this with, let's see, let's go down, let's do this. Now we've got XOG, get rid of all that. So we know that XOG.transpose gets us part of the way. We know that that's true, okay? And that's what we've got right here. We've got XOG right here is XOG transpose. Okay, now we have to multiply that times XOG. So let's try something. What would be something good to try? Yeah, sounds good to me. All right, let's see what happens. All right, it worked. Okay, so lesson, very important lesson. Try the intuitive thing. Don't make it hard. If somebody has designed something well, the intuitive thing will work. All right, okay, so we've got part of this. We've got this piece right here. Okay, and then we have to multiply it by XOG transpose. We sort of know how to do that, don't we? Yeah? So we're going to take this, we got this in parentheses, or actually, you know what? I'm sorry. The first thing we have to do is we have to take the inverse. We're up to here. We've got to find the inverse. Okay, so how do we find the inverse of a matrix? So this is going to be a matrix. You know, that creates a matrix. Now we want to take its inverse. So how are we going to figure that out? You even know the answer to that, don't you? What's the answer?
What we did originally was we had the data array. And we
Wait. Unless they want you to help. Okay. All right. You know the answer. The answer is you Google it. Okay. Oh, you're doing it back there. Matrix, inverse, Python. All right. And let's see here. NumPy, linear algebra. Oh, that sounds, lots of things sound encouraging here. Let's see. If you got a big page, you look for inverse. Okay. Well, okay, this is for linear algebra, but it says, it looks like it's just, let's see here. Yeah. What we want, let's see, you know what we may want to do here is instead of Python, let's do NumPy. Make it more specific. Okay, linear algebra, inverse of a matrix using NumPy. So what you're doing is, you know, like I said before, the usually it's the ones for Stack Overflow that are good. Yeah, that's what they've got over here. So, and this is in NumPy. So here's one right here. Let's try this. So copy that. Go over here. All right. So let's see. Let's do a new line here. New one. And if we go, this is what I just copied. All right. So we've got NP. Okay. So we wouldn't say NumPy because we imported NumPy as NP. Okay. So we'll use NP instead here. All right. And so that's fine. Inverse. We're not going to use X because we've got something else that we're doing here. We're going to actually, you know what? Let's do this. Let's call this X just for right now. So this is that multiplication we did of multiplying the transpose times the matrix, creating this over there. All right. So we've got that. Okay. So now, I'm sorry? D in front of INV? P in front of INP. Oh, well, I'm not sure that will work because of the packet structure here, but we can try it. Let's try that. Just P or NP? Oh, for the pseudo inverse. Oh, I misunderstood what you're saying. Yeah. Okay, so what we had before, okay, so we've got MP dot, it was what, linalg? Okay, and then X. Oops. Got it. Yes, that's true, because we want the pseudo inverse. Okay, and let's see what we've got. Okay, oh, I didn't print it. So it didn't complain, which is always good. And then if we print this, okay, that looks good. Looks like we got something. Okay, so where we are right now is it seems that we've got, we're at the point where we can say, we can substitute this in over here for x. Okay, and that should work. Good. And so what we've got right now is if we go back to the MATLAB code, we've gotten this far on this one statement. What are we going to do next? Time. Okay. All right. Good. All right. So I'll tell you, the next part would be is we would take the transpose, which we already know how to do, and then we multiply by this other matrix over here. Okay? All right, good. All right, how many did we go through today?
7.
Wonderful. That's what I was hoping to do. All right. How did people like it? This helpful? Okay, awesome. All right. Thank you.